All right, guys, we are going to today solve systems of equations by substitution. We have a few objectives here. So we're going to solve by substitution when both equations are in the y equals format. Fix that. Solve by substitution when one equation is in the y equals or the x equals format. And then we're going to understand the difference between no solution, infinite solution, and one solution when we solve in this substitution method. So let's just review the three types of solutions, what they look like graphically, and then what they're going to look like algebraically. So when you have one solution, that means you have different lines, and it's going to be that you have lines that intersect in one singular point. So right here would be your one point of intersection, and that is how you visually know that you have one solution. Algebraically, though, you're going to wind up coming up with an answer that's something like x equals 2, y equals 3. So you're going to solve equations today, not graphing, and you will get a distinct answer for both variables. Your answer would be 2, 3. Infinite solutions means that you have the exact same line. So that means you'd have a line, and then when you have your second line, it goes right on top of it. Now for today, when we solve, the way you're going to see this algebraically is you're going to have something that's like 10 equals 10. You're going to have no variables. They're going to completely cancel out, and it's going to be a true statement. So if you wind up with something that looks like this, 10 equals 10, where it's true with no variables, that's how we know we have infinite solutions. No solutions is when you have parallel lines, and parallel lines is when they don't intersect at all. And so the way that's going to look is something like 8 equals 10. That's going to be when you have no variables, but then it's going to be a false statement. So this is sort of like your reference sheet in your notes. All right, let's take a look at an example. Our first type of example is going to be solving when both equations are actually in the form of y equals. So what we're going to do is we're going to plug the first equation into the second equation. We are then going to solve for the variable, which is going to be our x value. Then we're going to plug your answer from step 2 into the first equation. And then we're going to solve for the second variable, which is going to be y. After that, just want to make sure that you state your answer. It's going to be the intersection point. So just as a reminder, when you do finally solve for both x and y, you do want to write it as an intersection point, x comma y, and then that's what you box. So let's take a look here. This problem has two equations, and they are both in the y equals format. So what we're going to do is we're going to take this first equation and I'm going to box what y equals, and I'm going to substitute it in for y in the other equation. So instead of y, I'm going to erase it and I'm going to put negative 7x minus 20 in its place, equals, and then the other part, so negative 6x minus 17. And now what we've done is we've created an equation that has only one variable. So let's go ahead and solve. We're going to add our 6x to the left. We get negative 1x minus 20 equals negative 17. I'm going to add the 20 to the right, and we get negative 1x equals 3. Divide by negative 1, and we get x equals negative 3. So that's the first part. Second part here is we take our answer and we plug it in to the first equation. So I'm going to take this right here, my first equation, which is y equals negative 7x minus 20. I'm going to take my answer, I'm going to plug it in where I see the x value. So we have y equals negative 7 parentheses negative 3 minus 20. Y equals 21 minus 20. Y equals 1. So what's your answer, though? The answer is negative 3, 1. This has one solution because we have an actual intersection point. It is the only place on the graph where those two lines would cross. Okay, now the second way we have this is when we're solving when only one of the equations is in the format of y equals or x equals. So step one, we're going to plug the equation that says y equals or x equals into the other equation. We're then going to solve for the variable that's in the equation we've created. We will plug your answer from step 2 into the y equals or x equals equation and solve for the second variable. And then again, we're going to state your answer, and it's going to be the intersection point. And then the intersection point, just as a reminder, is your x comma y value. So we're going to do a few examples like this, kind of go through that process. So in example 1 for this set of directions, we have two equations, but only one of them is in y equals. It's the first one. So I'm going to box the first one, and it is going to go in for y in the other equation because that's what it equals. This box equals y, and so I go in for y. So we have 7x plus 1 parentheses 2x minus 7 equals 11. 7x distribute the 1, so plus 2x distribute the 1 minus 7 equals 11. Combine our like terms. Those become 9x minus 7 equals 11. Add 7, 9x equals 18. Divide by 9, and we get that x equals 2. Now, if we go back up and look here, we're at this step that says plug your answer from step 2 that we just found into either the y equals or x equals equation. Well, we had a y equals equation this time. So we have y equals 2x minus 7. Well, we found that x is 2. So we're going to have y equals 2 parentheses 2 minus 7. Y equals 4 minus 7. Y equals negative 3. So our answer is 2 comma negative 3. And because it's a very specific point, this is when we have one solution. Okay, example 2. So in this problem, we have two equations, but one of them is in x equals. So we're going to go ahead and we're going to box the x equals equation. Now, because this equals x, that means it goes in for x. So we would have 3 and then parentheses 2y minus 8 plus 7y equals 2. We're going to distribute to get 6y minus 24 plus 7y equals 2. Underline our like terms. So we get 13y minus 24 equals 2. Add the 24, 13y equals 26. Divide by 13, we get y equals 2. Now we go ahead and we're going to take our answer, we're going to plug it back in to either the y equals or x equals. Well, in this case, we have an x equals. So I'm going to take my y equals 2, and I'm going to plug it in where I see y. So 2 parentheses 2 minus 8. X equals 4 minus 8. X equals negative 4. So what's my answer? Negative 4 comma 2. It has to be x and then y. And again, since this is one point, we would say that this is one solution. One solution happens most often. Occasionally we have infinite and no solution, and we'll see what that looks like in this next example. Okay, example 3 and the last one. So again, I have two equations. One of them is in y equals. So it's the second one this time. So this equals y, which means it's going to go in for y in the other equation. So we have negative 3 parentheses, negative 6x minus 20 minus 18x equals 60. We're going to distribute to get positive 18x, distribute again to get positive 60, minus 18x equals 60. We're going to combine our like terms. What happens is that 18x and negative 18x is 0x plus 60. Now, if you have 0x, what happens is they go away. We don't need them anymore, and we have 60 equals 60. Well, at this point, I have to stop. The whole point of this is to solve for the variable. If there is no more variable, then we're done. So there's no variable. And the question here is it true or false? Well, this is true. So if we have those two things, what we have for an answer is infinite solutions. And that means that they are the exact same line. That's what we would box.